Hello, and I am now going to be telling you about integrals, definite integrals. This is just the first part of the series, and this is how an integral looks like, what I just drew now, and a definite integral will have a lower limit, let's say 1, then upper limit, let's say 2. Okay, yeah. Okay, and we could now, I'm going to give you a few examples, and so you could try and get to understand this. Let's try with an integral of 8 dx, and we know that with let's try 2 to 4. Now this is the 8 is the same thing as 8 times x to the 0th power, because anything to the 0th power is 1, and we know that to get the derivative, we need to add 1 to the exponent of x, so x to the first, or just x, over 1, or just 8, and the answer to this is still just 8x. So let's try and plug in 4. 8 times 4 is 32, and we need to subtract from it 32. Let me just clear the screen. So 32 minus 32 minus let's try and plug in 2, which is 8 times 2, which is 16. So 32 minus 16 is just 16. So that's the answer to our problem. Now let me try and do one last. I have a limit of 5 minutes on my recorder, so I could only make this video 5 minutes long at maximum. So it needs to be it has to be maximum 4 minutes long. So but soon I'll try and pay for removing the 5 minute limit. But for now, let's just give you one last equation. And yeah, so let's try. Let's try 1 to 2 with 5 squared, or no, 5, let's just try 5 dx from 1 to 2. So let's try, and we know from our last problem that the derivative of 5 dx is just 5x. And yeah, we know that already. So we are gonna plug in 2 first. So then we get 5 times 2, which is just 10. Okay, I wrote that wrongly. 10. And for 1 it's 5, and 10 minus 5 equals 5, and that's our answer.